We will continue our discussion on reinforcement learning introduction. In last video we saw the different types of environment and we saw that environment can be either fully observable or partial observable. So this we call Markov decision process, and this formed the basis for POMDB, partially observable Markov decision process, where the state of the environment was known to the agent. An agent did not need to construct its own view of the environment. In this video, we will focus mainly on agent and the various components of this agent. So an agent has maximum it can have three components, but all of these components are not required, and some of these will be present and some of them will be absent, and we will see in further videos categorization of agents based on the presence or absence of some of these components. So an agent has policy, value function, and model. So let's see what is policy. So policy defines the agent's behavior. Like if agent's current state is S, and then what action should it take given the current state. So we will say that policy determines the agent's behavior. So this policy is defined for a given state, and this policy will determine what action should it take. So it's expected that we will define a policy which will help us in taking any action in a given state, and this policy can be either deterministic or stochastic. So deterministic means that this policy will explicitly say that if you are in this state, you have to take this action. So it's give a deterministic answer, whereas stochastic will give different sets of probabilities. It will give what is the probability that you take action A given state is S, whereas this deterministic policy will clearly say the action given a policy. So this A will be determined by policy function, whereas this probability of an action will be determined by this stochastic policy. Now let's look at value function, our second component of the agent. So it's a prediction of future rewards. So if we have defined a policy, then based on that policy, this value function will say that if from state S, what is the expected future reward. Over time. Given that you are in state S at a given time. So let's understand this clearly. So you define a policy and you are in some state, then you need some way of comparing which state would be better. So which state is a good state, which state is a bad state. So this goodness or badness of state is determined by expected future rewards from that state. So if a state S1 is expected to give more future reward, so if you expect that from state S1 you will get more future rewards than the state 2 with the same policy, then you will say that state S1 is better state, because the agent's main objective is to maximize the expected future rewards. So this value function is a prediction of future rewards, and it will help in comparing which state is better. So it's a parameter for determining the goodness or badness of a given state. Now let's look at the third component, which is model. So what is a model? So agent does not have always a clear view of the environment. Like we saw in some examples, a robot is walking somewhere in the room and it has a very limited view of the environment, and it has to make its decision based on that. It has to guess how environment will behave depending on what it has seen so far. So if this robot came this way and went here, and here we have some other paths, and this side also. So agent came through this path and is currently here. So it built some state of the environment like this, and it can see some path ahead. So it has this view of the environment, but the complete environment is this. So this view of environment that is created using the user's or the agent's experience and observations, this will be model. So based on this only, the agent will guess how the environment is behaving. The agent tries to build a view of the environment. So model is used to predict what environment will do next. So it's not the actual environment, but a view of the environment, agent's view of the environment, and it will have two components: transition model and rewards model. This transition model, it will determine what is the probability of going from state S prime from state S given an action A. And this reward model will say the expected reward if the current state is S and an action A is taken. So this model have two parts: transition model and rewards model. Now let's look at some examples. So we have a grid, and the agent is currently here. So this is the starting point and this is the ending point or the goal, and some of these are bricks that user cannot the agent cannot enter these places. And it's given that every state has some reward. -1, if this is 0 0 0 1, -1, -2, -1, -2, -1, and so on. So what the agent will do, it will, let's say, come here. Its aim is to reach the goal in the minimum possible time. That is, it has to get maximum rewards. So we have -3 here, -2 here, -2, and -1. So if it goes this way, it will have the maximum score. So in the model's point of view, so the agent will just see this part of the environment because it has came this way. So this is a model because it's the agent view of environment. It does not know about the other part of the environment. Now for the same example, we will see what are policy and value functions. So we have seen model. So this will be the model and the corresponding rewards. The agent has no idea about other parts of the environment. And let's see what is the policy. So the policy is if the model agent is here, it goes upwards, here also upwards, here also upwards, this way, and it reaches the goal. So these arrows would determine the policy. So based on the policy, agent see here that we have to go upward if the state is this. So it goes up, and here it will see that in this state I have to go up, and here it has to go right. So these arrows denote the policy. These are policies. Now value function. Value function is the expected future reward. So given a policy, what is the expected future reward? So this is very close to goal. This cell is the goal. So here it's -2. So if it's in this state, it will just get this reward -2, and if it's in this state, it's -3. If it's here, it will be -5, and here it will be -3 because here the policy is to go this way, and this cell had a reward of -1, and this cell has reward of -2, and this cell it will go up, so we will add this reward. So it's -5 here and -6 here. and it's -7 here and -8 here. So this state has the maximum future reward and this state has the minimum future reward. So the agent will not go this way because it sees that here the from this state the value function shows that. So if this coordinate is 1 0 and this coordinate is 0 1, then v pi 0 1 is equal to -6 and v pi 1 0 is equal to -8. So we will say that so state 0 1 is better and the agent will go to this state. So this value function is just representation, it just calculates what how good a state is. So if you go to state S prime from state S, what is the expected future reward, and we will try to go to such states from where the expected reward is maximum or the value function gives higher value to those states. So these are the major three components of agent. In the next video we will categorize the agents depending on various factor. So it has based on these three components only. So how can we categorize agents depending on policy, value function and model. So stay tuned for that and give your feedbacks in the comment section below and don't forget to subscribe my channel. Thank you.